Hello everyone, this next talk is going to be in English, and Omri is going to tell us about fighting bias in AI.
Yeah, so hi everyone, I'm Omri. I'm a PhD student at the Max Planck Institute. Perfect. And I will talk a little bit about my research on AI and bias in AI. So this talk is divided into 3 acts. So if you feel like you're losing me at some point, you can just easily jump back up in the next act. And in our first act, I want to talk about AI, or short for artificial intelligence. And the first thing I want to say about AI is that it is basically a buzzword that is used to make it appear more sophisticated and intimidating than it actually is. And in reality, when we talk about artificial intelligence, what we actually mean is machine learning. And in order to understand what machine learning is, I want to start by playing a simple game. I will ask a question, and I want you to answer quickly. If the answer is yes, just raise your hand. If the answer is no, then lower your hand. So, did you understand the rules of the game? Okay, excellent. Hands up. Perfect. Okay. Is this person wearing glasses? Okay, great. Is this person smiling? Okay. And does this person have short hair? Okay, so I'm not fully agreeing. Is this person good looking? Okay, thank you very much for the boost in self-esteem. I really needed that. And who wants to continue playing for 100 and 1,000 more rounds? Yeah, not many people, I see. And that's understandable, because if we do it for a long time, it will start become repetitive and tedious. But what if it was your daily job? That's what you had to do every day for a few hours. Look, not maybe at images, but just numbers, and give decision whether someone should get a bank loan or whether a felon might commit a crime again. This will become tedious and repetitive, and we don't really like to do those kind of tasks. But who really does like tedious and repetitive jobs? Computers. And that's exactly what we made them for. And the question is really, how do we make those computers do those tasks? So, because we don't know really how to explain to a computer what glasses are, like from the first question, or if the question is a bit ambiguous, like short hair or smiling, we don't really know how to translate that into computer code. But the thing to remember is that when we were born, we also did not really know what glasses were. We were just interacting with glasses, we saw glasses, we saw people in glasses, we were explained what glasses are, and we learned through that. And machine learning tries to ask whether a computer can also learn from just looking at the real world. And this is essentially what machine learning is. We look at the real world and try to answer just a very simple question. And for example, whether a person wears glasses. So just give data, change the person, and we get an answer. Just a very simple question. And because it is a talk about AI, I am obligated to mention ChatGPT and say, yes, also ChatGPT answers a very simple question. We can ask it everything, and it seems like it answers everything, but it is basically an illusion. It just answers the question, what will be the next word in the text? And if you keep asking that, you will get a very long text. But back to machine learning. So I described essentially what machine learning is, but how it is actually done. So we have a few steps. First of all, we start with the data. The data is supposed to represent the real world. So in this case, our data that we learn from is those 2 pictures, one a person with glasses, so obviously he will have the word yes, and one without glasses, so the answer is no. But if I just show you those 2 pictures and ask you, okay, why does this get a yes and why does this get a no, and you need to try to answer for a new person, it's very difficult to say that it's because of the glasses, because there are so many differences between the pictures. Like the hair is different, the background is different, the colors are different. So in order to solve that, we add thousands and thousands and as much data as we can get, as many questions and answers as we can get. Then the more samples, the more different people we have, then the only consistent difference will be whether the person is wearing glasses or not. And that is exactly what we try to figure out by having all of the data. And in order to learn from that, we use some learning algorithm, which is just some box that we put all the data in, and it gives us the machine. This small machine just it only wants to see a person and tell us whether they were wearing glasses or not. So let's give it to people, and yeah, it was correct. The third person does wear glasses, the bottom one doesn't. And this step, the answering step, after the machine was trained, is called the inference step. But it also sometimes mentioned as the algorithm, like when you talk about the Netflix algorithm or the Spotify algorithm to predict our next content. This is not really the algorithm, but just the output of this machine that we trained. Now, this is a very ideal scenario. It was correct for both images, but will a machine that we train will always be correct? And the answer is, of course, not. So, for example, maybe our data is not good enough. Like in the picture at the bottom, maybe it appears a bit that this person does not wear glasses, but they indeed do. So if our data is not correct, then obviously the machine that we train will also not be correct. So let's fix that. Let's put a yes there. Will it be okay now? Also, not necessarily, because it also depends on how we take the data and turn it into a machine. So if we're very lazy and don't want to compute a lot of functions, algorithms, we can, for example, just ask, okay, let's always give the answer that is most common. So we have 2 yeses, 1 no, 2 is more than 1, let's always answer yes. And of course, for people who don't wear glasses, the machine will be wrong. And the question now is whether if we find a machine that has the least errors, is that the best machine we can get? So far, the answer, from what we saw so far, the answer would be yes. And that brings us to the second act of bias in AI, or the paradox of fairness in machine learning. And why am I mentioning fairness? Because as it turns out, for example, a few years ago, Google classified black people as gorillas. And we found that AI is kind of discriminative against people of color. But not only color, it also discriminated against women, where like they did not allow women to get the loan that they need. So we have some problem of fairness. Even though this AI was trying to minimize the errors, we have some problem of fairness. And we need to understand how to solve it. So there are a few sources of unfairness in machine learning. So here we have our pipeline of learning. So we have the data and the algorithm. So first of all, the data might have bias in it, because the data is supposed to represent the world, and as some of you may know, the world is not fair. And if the world is not fair, the data may not be fair, and thus the machine learning may also not be fair. But also the algorithm itself might introduce bias into the system, because if we want to minimize the error, and we have a demographic majority and a demographic minority, then if we just focus on the demographic majority, we already minimize a lot of the errors, and while the demographic minority suffers. So we have the sources, but if we want to really solve it, we need a way to quantify it. Like, if we have 2 machines, how can we say that one is fair and one isn't? And in computer science, we really like numbers, and unfortunately, fairness is a quite philosophical idea. So if you go into Wikipedia and try to look for fairness in machine learning, you see that there are many, many mathematical definitions of fairness, because it is a very obscure philosophical concept. But for the sake of this talk, what we do, we divide the population into a demographic majority and a demographic minority, and look how the machine treats both the majority and the minority. If there is a big difference in how they're being treated, then we say that there is high unfairness, and if the treatment is equal, we say there's zero unfairness. Perfect. So now we have the tools in order to understand and solve this problem, and we can go back to our training pipeline where we have the data, the learning, and the answering, and try to figure out how we can fix fairness. So first of all, we can just, if we know there's bias in the data, we can just fix the data. And we have a lot of methods that try to find the bias and remove it from the data. And this is the pre-processing family, because we process the data, we do it before we process the data, do the learning. Then we can actually control the learning algorithm itself. Instead of minimizing error, we minimize error and unfairness. And this is the in-processing. Or finally, if we don't want to train the whole system again, we can just tweak the answers, and to make them appear more fair. So we solved fairness, that's it, we can all go home. But actually still a little bit of a problem. So to understand the graph, let's imagine we're training a new machine, but we don't care about fairness, we just minimize the error. In this case, we will have this red dot here. What does this red dot mean? So on the x-axis, we have the error percentages. How many mistakes does this machine have? And on the y-axis, we have the unfairness. So essentially, we want the machine to be at the bottom left, somewhere here. So very low error and very low unfairness. So again, if we would just want to minimize error, then we'll get a very high unfairness. Now, the blue stars represent different versions of those post-processing fairness algorithms. And as you can see, all the different versions create some kind of a line, but none of those points get to the left and to the bottom. So it seems that if we want to get fairness, we have to get some error as well. And you might say, okay, maybe this is a problem with the algorithm or the data, but no, this happens across many data sets and over algorithm. And this is an inherent trade-off of fairness in machine learning. If we want more fairness, we have to pay with more error. And this is the paradox I want to talk about. So we have a lot of research that tries to come up with those fairness solutions, but those fairness solutions incur error. And if you have error, companies that might use machine learning will lose profit. So they don't really want to deploy those solutions. So we have research that provides solutions that companies may not want. So the fairness, this trade-off in fairness and error is inherent and cannot be solved. So, but if the companies don't want to use fair methods, is there something still that we can do? And this brings us to our third and final act of fighting bias in AI. And can we, the ordinary people, do something about that? Collective action is a term we borrow from economics, where a group of people can share the resources and collectively act in order to achieve a unified goal. And this was already done a lot in certain apps like Uber drivers, declining calls in order to increase prices, and all sorts of ways to go against the system. And what we want to ask is whether those kind of actions can also be used to promote fairness. So we live in a data-driven world, and I assume every person in this audience can identify every logo and every company on this screen. And I believe every person in the audience also uses at least one of those services. And the thing that is shared by all of those web applications is that they all collect our data. They collect only information, what we liked, what we clicked, how much time do we spend on the platform, our internet history maybe, and anything they can collect on us. And all this data is used to train the models in order to better advertise things to us and make profit out of us. And yes, this does look scary, but the important thing to remember here is that it is our data. We control that. We control what the company sees and what they use. So this gives us the agency over the data part in the learning pipeline of those companies. So if you're a minority that wants to promote fairness and you know the companies don't really care, is there something you can do? Then yes, you can coordinate within the minority how you interact with those websites. So I will not go into too much technical detail, but I will show an example of how effective it can be. So here, in this small simplified problem, you can think about the color, the blue and the orange, about the answer to the question. For example, whether a person wears glasses. So let's say that blue means that the person wears glasses, and orange means that they do not wear glasses. Then we have the circles and the X's. The circles represent the demographic majority, and the X's represent the demographic minority. And if we train a machine that just reduces error, it gives us this colorful background, where everything that is in the orange part will defined as having glasses, and everything in the blue part that is not having glasses. And now where the collective action comes into play is that if only 6 people out of the minority change how they interact with the website, with the platform, then the error stays the same, but the unfairness reduces significantly. So this is very good news. And so we tried on a few data sets just to understand, for example, how many people do we actually need from the minority in order to get the best fairness. And across most data sets, we changed the percentage of the minority that changes their interaction with the platform and measured what is the best possible fairness they can get. And we found that for all data sets, it is about between 20 and 30% out of the minority. And it depends on the minority, it may be not that much a lot of people. We also wanted to compare it with the previous method that they found, but the methods that were designed for the companies to use. So those are the blue and yellow lines over here, and again, so we have the arrow on the x-axis and unfairness in the y-axis. And these figures tell us two very interesting things. First of all, if the minority attempts to promote fairness through collective action, it cannot get perfect fairness, while the company can get a perfect fairness. But on the other hand, while they're not able to get perfect fairness, they are still able to get much better fairness and much lower error than the other solution are able to. So this is also very promising and maybe hints that there could be some collaboration between those companies, those internet techs, and the minorities. So this is only the first step that we try to do in order to look at the problem of fairness from a different angle, from the user side and not from the company side. So maybe it can improve, maybe it can be generalized for more problems, and maybe it can initiate ideas into other uses for social good. So this is one of our meetings with my collaborators, Amartya Sinyal and Alex Difrea, discussing results and what other thing we can do. And I know I discussed a lot of topics today, so I want to recap everything. So I started by explaining that AI is basically machine learning, and it's just how we take a lot of data to answer just one very simple question. Then I said that we have a problem of fairness, and fairness leads to error in machine learning. And because of this error, a lot of applications remain unfair. And finally, what the main point of this idea is that together we can collaborate in order to affect those machine learning algorithms and get fairness or other social good. And I want to finish that if you want to see those slides or read a research paper that we wrote, which have much more technical details and much more definitions, you can just scan the QR code and find the files there. So thank you very much for your attention, and if you have any questions, feel free to ask. Thank you very much.
Thank you, Henri. While we have time for questions, but just 1 minute or so, roughly, I guess. So if there are questions, just raise your hand right now. Is this a question? Yes.
Okay. So you don't need to know anything about the model. You don't need any information. It's model agnostic, as we say, which you just need to know who are the other minority members and collaborate with them. And then you just share your own information with each other. That's all you need. Yeah. So we use ideas from methods connected to counterfactual fairness, sort of method that asks, what would the answer be if you were from the majority and not the minority? And we use very simplified ways to emulate that, but there are more sophisticated ways to compute that and maybe get better results. Yeah, so they do need some information about the majority, but not much. And then by looking at that information, they can try to guess how the answer for them should change according to if they were from a different demographic group.
Are there other questions? Short questions, not too long questions. One.
Yeah.
So. An example of what a collective action could be.
Yeah, so for example, in In content recommendation, like in Netflix or Spotify, maybe the AI might focus on your demographic group and not necessarily what you individually like. So it might recommend that. So if you change together with other people, the stuff you listen to, then it can affect the algorithm to answer more your individual wants and not necessarily demographic ones.
So I'm going to close the question session. Thank you, Ori, again.
Thank you very much.
Applause, please.
Thank you.